So next concept is determinants. Uh, Determinant, here you have to learn the definition of the determinant. What is determinant? Determinant is a unique real number associated with every square matrix of order n. Is a unique number associated with matrix, square matrix. Only square matrix. Determinant can't exist for the rectangular matrices. And it is denoted by det A or like this. With vertical lines, you can denote it. Here you have to learn minor. What is a minor? Minor is a determinant of order n. Minor is a determinant of order n. It is denoted by Mij. Mij. That means minus will be calculated with deleting the row and column of the particular element. And for example, if you consider 1, 2, 3, 4, so take one example to understand this. So here, what is A11? 1. A12 is 2. A21 is 3. A22 is 4. So now I want M11. M11 means delete this row and column. What you are having, that will be the minor of 2 by 2 matrix. And similarly, you can define the rest of the elements minor. And cofactor. Cofactor is denoted by Aij, and sometimes it is also denoted by Cij. And this will be equal to minus 1 to the power of I plus j into Mij, where Mij is the minor of the element. Okay, and properties of determinants. Properties of determinants will be already deleted, it was, but sometimes some questions will be framed. So that's why you have to learn some properties. Determinant of a power n is nothing but det a power n. Det a power n. Only this property you should know. And more properties, if determinant of a is equal to 0, then it is called singular. Singular. If det a is not 0, then it is called non-singular. Singular, non-singular. And most of the cases, determinant will be used to calculate the area of the triangle. Area of triangle. So 1 by 2 into x1, y1, 1, x2, y2, 1, x3, y3, 1. x3, y3, 1. Area of the triangle, it is always positive value. Okay, take as because area cannot be a negative value. If area of the triangle is, if delta means area of the triangle, if it was 0, that means the points are collinear. Points are collinear. Adjoint of the matrix. Adjoint of the matrix. You know how to calculate the adjoint of the matrix? And I will discuss here some properties of adjoint. Adjoint of A. Adjoint of a matrix. Adjoint of a matrix. A matrix which is formed by the cofactors, which is formed by cofactors, transpose. Cofactors transpose is called adjoint matrix. And properties of adjoint. adjoint is denoted by ADJ A. Suppose take ADJ of AB is equal to adjoint of B into adjoint of A. Okay. And determinant of this is most important point. Adjoint of A, determinant of adjoint A is equal to det A power n minus 1. And here det A should not be 0. And the adjoint of A transpose, adjoint of A dash, adjoint of A dash is equal to adjoint A whole dash. Adjoint A whole dash. Adjoint of adjoint A is equal to adjoint of adjoint A is equal to det A power n minus 2 into A, where n is the order of the matrix. N is the order of the matrix. A into adjoint A is equal to det A, and this is also equal to adjoint A into A. Adjoint A into A. And Cramer's rule and matrix inversion method. Cramer's rule, we already know that how to do that. Cramer's rule. Cramer's rule will be x value will be delta x by delta, okay? And y value is equal to delta y by delta. And z is equal to delta z by delta. And delta x means, the first column of the matrix replaced by the B matrix. Also, delta y means the middle column will be replaced by the B matrix, and third column will be replaced by the last column. If delta is not equal to 0, then Cramer's rule exists. Otherwise, it was not exist. Okay. If delta is equal to 0, then what happens? If delta is equal to 0, then delta 1, delta 2, if delta is equal to 0, then it is called in also delta is equal to 0 means what? Det A is 0. And also adjoint A into B is also 0. Adjoint A into B is also 0. Then system has infinite solutions. System is inconsistent and infinite number of solutions. Okay. Infinite solutions. Infinite solutions. If det A is equal to 0 and adjoint A into B not 0, then no solution. Then no solution. If det A not equal to 0, we have unique solution. Okay. And some of the inverse properties. Inverse matrix and its properties. So every invertible matrix possesses a unique solution. And if A is invertible, then its inverse denoted by A inverse. And we have A inverse is equal to 1 by det A into adjoint A. This is the formula of A inverse. And take two matrices A into B whole inverse will be defined by B inverse A inverse. And A inverse determinant will be 1 by det A. 1 by det A. These are the main important formulas. And also if transpose is there and whole inverse applied and A inverse whole dash, And in this case, you can say it is consistent and infinite solutions. And in this case, you can say inconsistent, no solution. And for not equal to 0, our system has consistent and okay. For homogeneous type also it will be applied. This is the concept in the matrix multiplication. Okay. Differentiation. The basic formulas are d by dx of x power n is equal to n into x power n minus 1. And you know that d by dx of constant is 0. Okay. And d by dx of x is equal to 1. D by dx of x square is equal to 2x. D by dx of x cube is equal to 3x square. Okay. D by dx of x power 4 is equal to 4 into x cube. D by dx of x power 5 is equal to 5 into x power 4. D by dx of x power 6 is equal to 6 into x power 5. Okay, up to 6 you have to learn. D by dx of e power x is equal to e power x. D by dx of a power x is equal to a power x into log a. D by dx of mod x is equal to mod x by x. D by dx of log x is equal to 1 by x. Okay. Next, d by dx of 1 by x is equal to minus 1 by x square. D by dx of 1 by x square is equal to minus 2 by x cube. D by dx of 1 by x cube is equal to minus 3 by x power 4. Next, d by dx of 1 by x power 4 is equal to minus 4 by x power 5. D by dx of 1 by x power 5 is equal to minus 5 by x power 6. Up to 6 you have to learn, okay? D by dx of 1 by x power 6 is equal to minus 6 by x power 7. And d by dx of root x is equal to 1 by 2 root x. Next, d by dx of 1 by root x is equal to minus 1 by 2x root x. And a few more formulas. D by dx of ax plus b by cx plus d is equal to ad minus bc by cx plus d whole square. Okay. And d by dx of a into f of x plus b by c into f of x plus d is equal to ad minus bc by c into f of x plus d whole square into f dash x. Okay. This is all multiplication with f dash x. And d by dx of f of x power g of x. F of x power g of x.